Hey guys, welcome back. We are on section 2.3, which is the inverse of a matrix, one of the most important sections in our book. So in this section, we're going to talk about the definition of the inverse of a matrix, the uniqueness of a matrix, of an inverse matrix, how to find them, a joining matrix, the properties of inverses, the inverse of a square, finding the inverse of a matrix product, the cancellation properties, and how to solve system of equations, okay? So I'm going to break up this section into two videos. It's really not that bad. I think one of the most important things that you want to take with you are the properties and the theorems. The procedure on how to do it is a piece of cake. You just keep repeating the process and then you get the hang of it. But really understanding the properties and the theorems is the most important part. So let's get to it. So if I have a matrix A and a matrix B, and I multiply them and I take the product of them, if that product gives me the identity matrix, A and B are inverses. So let's take a look at some of the key words. An n by n matrix A is invertible or non-singular when there exists an n by n matrix B such that AB is equal to BA, which equals the identity matrix I. The matrix B is the inverse of A. So a matrix that does not have an inverse is called what we say singular or non-invertible. If A is an invertible matrix, then its inverse is unique. The inverse of A is then noted by A to the negative 1. Okay, so if A does have an inverse, that inverse is unique, okay? Moving along, let's just take a look about how we do this. I want to show that A and B are inverses of one another. So I said, let us use the first definition of the inverse of a matrix to show that A and B are inverses of one another. Well, how do we do that? Okay, so I did not do the work here. That's fine. I'm going to take A times B, okay? I'll do this out with you guys. This times this. And we learned in the last section, in order to multiply matrices, you're going to take the first row, first column. So negative 1 times 1 plus 2 times 1. Okay, so that goes for the first one. We're going to do the first row, second column. So first row, negative 1 times negative 2 is 2. 2 times negative 1 is negative 2. Okay, then we're going to do the second row, first column. And we're going to go negative 1 times 1 is 0. I'm sorry, negative 1 times 1 is negative 1 plus 1 times 1. And then we're going to do the second row, second column. So negative 1 times 1, negative 1. Sorry, let me do this again. Second row, second column. Negative 1 times negative 2 is 2. And then 1 times negative 1 is negative 1. And therefore, if you take a look at this, this is going to be 1. This is going to be 0. This is going to be 0. This is going to be 1. You get the identity matrix, and that shows that A and B are inverses of one another. So remember, the identity goes 1, everything below is 0, then a 0, everything, then a 1, and then everything below that is 0, and so on. So 1, 0, 0, 1. So therefore, A and B are inverses of each other. In this video, in this slide, look what time it is. It's 10:51, so I'm exhausted, so I apologize. How do we find the inverse if I don't give you the B? Well, I know A times B must equal to I. So I'm just going to call B X right now. So A times X is equal to I. I'm going to say A is 1, 4, negative 1, negative 3, which is this. And then I'm going to call this X, first row, first column, first row, second column, second row, first column, second row, second column. So that's how we should denote our variables, okay, or our elements. We know that when we multiply this, you have to get that 1, 0, 0, 1. So what we're going to do in this case is we're going to do the same thing that we were doing earlier, where we were basically figuring out first row, first column. So negative 1 times x to the 11th, x in the first row, first column, plus 4 times x in the second row, first column, has to equal to that 1. When you go to do this person here, you're going to go 1 times x plus, so 1 times x, and then 4 times x to 2. And that has to equal to this person. And this is what we're basically going to set it up. So I can automatically see, check this out, guys. This crosses off. 4 minus 3 is going to be 1, and 1 plus 0 is 1. Therefore, this is x in the second row, first column is 1. So this person here is 1. And then when you go back to substitute the 1 into this place here, I get 1 x in the first row, first column, plus 4 equals 1. Therefore, that person is going to equal to -3, right? So I'm going to go on to the next page where I did this here, and then we're going to get 1, -3, 1, -4. Therefore, I'm going to put -3 here because that's first row, first column. I'm going to put 1 here, second row, first column. First row, second column becomes a -4 and 1. So what I did, guys, was I made this, I solved this separately, and then I'm going to solve this separately. Once you solve those separately, you come up with your answers. Fantastic. So instead of solving them separately, what I can do is I can join them together. You see, there's a lot of commonality, right? So we have this, and then this, right? And then this, and we have this 1, 0, 0, 1. Why don't we instead just put the coefficients together, right? So take the entire 1, 4, -1, -3, 1, 4, -1, -3, and join them with 1, 0, 0, 1, which is the identity element. If you guys put a matrix and the identity element next to it and use your reduced row echelon form to get 1, 0, 0, 1 on the other side, okay, then your answer that's left over, in this case -3, -4, 1, 1, is going to be the inverse. So a -1 is going to be -3, -4, 1, 1, and that's exactly what we got here. So this process is called adjoining matrix I, which is the identity, to matrix A. So in order to find an inverse, you're going to take the matrix and connect it to the identity element, row reduce it until you get 1, 0, 0, 1 on the other side, and then this would be your inverse, okay? So that's what you would do there. So I, in this case, am going to show that, or I'm going to just find the inverse. I'm not going to show the next example. I'm going to show there is no inverse, but find the inverse of the matrix of this. Check this out. I write down the A here, and then I write down I here, and then I'm going to get I here, which I'm not going to show you the steps, and then you're going to get the inverse here. So all you have to do is keep row reducing until this becomes the inverse on this side, and now this is your answer, okay? Non-singular is the term to say that A has an inverse, okay? So that's how you do that. And then in this part, we're going to say this is singular, show that A has no inverse. I did the same thing. I line it up with the identity, and then I swap, and I try my best, but this is, I know I'm done here, because do you guys remember, if you have zeros, then you're done and you can't reduce this anymore. So we cannot write as I times A inverse, I should say, but we can't write it in that format, and therefore it has no inverse, okay? I believe I want to stop here, and then I can show you in the next video how to do a 2 by 2 matrix, how to find the inverse even faster. So come back for this.